This is my Rube Goldberg machine. First I started with the screw, so I would push the train down the screw, which would then hit this ball, and the ball would go down the inclined plane, which would then hit the rolling pin, which is meant to be a wheel and axle. So then the rolling pin would roll down and hit the book, and then the book would snap the scissors so that they cut the string that's attached to the moving car. And the scissors are meant to be a wedge. And then the car would hit the books, which are my lever. They're taking place of dominoes. And then that would pull down a weight, which would set off the pulley that will zipper the jacket on my American Girl doll. So one of the first things I did was find out where there would be an energy transfer. And I realized that one of those places would be with the rolling pin, so that when the ball comes down with its and it has kinetic energy, it would hit the rolling pin, which right now had, like when it's sitting still, would have potential energy, and then the ball would transfer the energy to the rolling pin, which would then roll down the string, which as it's rolling down it has kinetic energy, and as it hits the book, it passes off or transfers its kinetic energy to the book and is then left with potential energy. The next thing I found was where work was being done, and I used the inclined plane for that as my example. And an inclined plane, or in this case a ramp, makes the work of moving things easier. And to find work, you use the equation work equals force times distance. And when you change the distance of a ramp or an inclined plane, or make it longer, change the slope to make it greater, there is less force, but then the work is the same as before. So either way, work is being done here, no matter how long or whatever the slope is. So the work being done with the inclined plane is making it easier for the ball to roll down to hit the rolling pin. Alright, so the next thing I found was where momentum was being conserved, and for this I used the books, which were similar to the concept of dominoes. So there's already a certain amount of momentum that is present here, but when the first book falls and hits the next one, its momentum is transferred from there, and then that one transfers and transfers until the end. But at the end, momentum is conserved. It's the same amount as was in the beginning with the first book. So the last thing that I found for my Rube Goldberg machine was a mechanical advantage of one of the simple machines. And so for this, I again chose the inclined plane. And to find the mechanical advantage of an inclined plane, in this case a ramp, you do the slope, which is right here, over the height of the inclined plane, and that equals mechanical advantage. And so when I measured it, the slope was 28 centimeters and the height was 14 centimeters, which makes a mechanical advantage of 2. Okay, so I'm going to start my Rube Goldberg machine by pushing the train down. Which zipped the jacket. Just as proof, her jacket is starting unzipped and will be until I zip it at the end. The machine works. Alright, so now I'm going to start the machine again. Send the chain down. And now her jacket's zipped.